Hello everyone, I'm Jiajia Shen, Research Associate working on well-behaved nonlinear structures under the supervision of Dr. Groh and Dr. Pirrera. Today, I will give a brief introduction on our work on programming the wrinkling patterns in compliant bilayer structures. The wrinkling of multilayer systems is a common phenomenon can be seen in biological systems. Understanding the mechanics of wrinkling behavior in these systems can help understand the growth mechanism and help the pre-diagnose of some potential diseases. Wrinkling is also seen as defects in the manufacturing of composites. Understanding the formation of wrinkling can shed light on the manufacturing of wrinkling-free composites. This is what we want to do next. Recently, wrinkling began to be exploited as benefits in high added value manufacturing. For instance, wrinkling is exploited to manufacture flexible electronics attached on the human skin to monitor people's health condition. For the manufacturing of these stretchable electronics, the stiff and brittle electronics are initially pre-compressed in a wrinkling pattern onto the soft and stretchable substrate so that it can accommodate large stress without fracture during their working condition. Now, let's look at the manufacturing procedure of bilayer system to see how we introduce pre-stretch in the substrate. Initially, the stress-free substrate made of PDMS with length L0 is put on the mounting layer. Then, the substrate is pre-stretched into length L. Subsequently, the top layer will be stiffened using chemical treatment. After that, a bilayer with stiff film and a compliant pre-stretched substrate is manufactured. When we compress the bilayer, the wrinkling pattern will form. However, when the pre-compression introduced in the substrate is high, the wrinkling pattern will be irregular and chaotic. The photo shows the wrinkling pattern of bilayer with the pre-compression level in the substrate being 0.7 and the applied nominal compression being 0.11. Currently, there do not exist an effective technique to control the wrinkling pattern and their progression in these cases. And it is also infeasible to predict the highly nonlinear response using the existing commercial FE packages. To address the problem, we developed an FE model for bilayers with highly pre-compressed substrate in our in-house FE program and adopt the generalized path-following solver to trace the wrinkling progression. For the first time, we identified that there coexist a variety of different stable wrinkling patterns. For clarity, we only present 4 characteristic stable wrinkling patterns, and there are 4 different relationship here. We call these regular stable wrinkling patterns as basic building blocks. The distance between the localizations are the characteristics wavelengths of the building blocks. In reality, the formation of the wrinkling pattern will be determined by the initial imperfections in bilayers. The randomness of initial imperfections and coexistence of a variety of different stable building blocks lead to the so-called chaotic and irregular wrinkling patterns. Based on the understanding of the nonlinear mechanics, we developed a technique called model nudging to tailor the wrinkling pattern progression by seeding localized dents, with the distance being the wavelength of the basic building blocks. In this way, we can make the bilayer wrinkle in a desired regular pattern. Thanks for your attention.